All right, here we go. So finally, bug example. Let's have a look.
I like the pizza burgers.
Click. And so they're saying a bug is moving along the right side of the parabola y equals x squared at a rate such that its distance from the origin is increasing at 2 centimeters per minute. At what rates are the x and y coordinates of the bug increasing when the bug is at the point 636? Okay. So, I mean, if you want to, the picture is pretty simple, right? Here's the path the bug is following. It's on the right side of this parabola. And so it's up here, and it's got coordinates x and y, and we're saying that the distance is s, right? So we can just create this right triangle like that. Does that make sense? Yeah. Okay, I mean, that's just distance formula, right? Distance formula is just Pythagorean theorem. That's all it is. Okay, so then there's our picture. What are our snapshot values here? So step one is we have to define the variables and what it is we're looking for.
E dot equals
Okay, so what equals 2?
D dot.
Well, okay, or I called it S.
S, okay, S dot.
S dot equals 2, and we got our units. Okay, what are we trying to find? I guess, yeah, what are we trying to find? What else do we know?
X is 6, Y is 30.
What are we trying to find?
S is rate of X and Y.
Okay, so X dot and Y dot?
Yeah.
That make sense? Okay, so there's step one. That's how you should write it. Okay, next step. Well, we gotta
S squared.
Oh.
come up with a parent
Yeah,
equation.
yeah.
Good. So and that's just, distance formula is just Pythagorean theorem, right? So we've got s squared equals x squared plus y squared, okay? Don't confuse that with the function. That's just our distance function, right? That's not the path. The path is the parabola y equals x squared. Now what?
Now,
Would you input your y into the
Good,
equation?
good. See, here's where the road parts, and we could either just power through this and differentiate implicitly, but that's the wrong turn. I mean, it's gonna work, but it's a lot more work to do, right? Then we'd end up with lots of different variables, s's, s dots, x's, x dot, y's, y dots, to plug into that single equation, which is harder to deal with, right? So instead, we take advantage of the fact that we've got a secondary equation that relates x's and y's, right? So then we can substitute right there, and we get s squared equals x squared plus x squared squared, which is what?
X
Good. Now we've got s as a function of x only. Okay? Now what?
and
Differentiate. So what do I get? 2s
S
s dot equals
2
plus
4
x dot. Okay? And if I want to, I can factor out, well, I don't factor, we'll just leave it like that, that's fine. So I'm gonna solve for x dot now, right? I can divide everything by 2. So that becomes 2, right? Now I'm gonna solve for x dot. So I guess I do have to factor out an x dot, don't I? Because I'm solving for x dot. So I get s dot equals x plus 2x cubed x dot. Right? Now what? Okay, good. Divide by x plus 2x cubed. So x dot equals s dot divided by x plus 2x cubed. I don't need parentheses. Okay. And then I would just plug chug, right? But what am I missing?
S.
An s. So what are my options?
Oh, you can technically.
Okay, so I could just, one thing I could do is solve for s right here, right? S equals square root of x squared plus x to the fourth, right? And how come really technically it's plus or minus, but why wouldn't I take the minus? Because it can't be negative, it's a distance, right? So we're only taking the positive distance. And so one thing I could do is I could just plug that in. This is what I would do, but you can take your pick. You could plug this in right down here for s. And then all I've got x dot in terms of only things that I know, right? So I've got my square root of x squared plus x to the fourth s dot divided by x plus 2x cubed. And here's where you could just plug all this in on, like, would you guys use probably your calculators, or would you use Desmos, or what would you use?
Whatever.
Whatever, right? So say we use Desmos. Just want to show you here. I'm going to show you a little trick. I'm going to show you a trick on both your calculators and Desmos. And this is kind of a good practical trick to know. I don't want to do this. Let me, okay. I need to move this around a little bit. So that's what we want to, oops. So there's our values we know. And here's the expression we're trying to evaluate. Oops, darn it. Okay, so if we use Desmos, doesn't matter which one you use. We could use the scientific even. Doesn't matter. Doesn't even have to be the graphing calculator. Here's what you can do. You can define a function in terms of a variable, right? So we could do something like we could do the square root of x squared plus x to the fourth times, what's s? What was it? S dot is 2, so just times 2. Whoops, got to be outside. There we go. Times 2, all divided by x plus 2x cubed. And I'm going to call this whole thing f of x. Okay? All I have to do down here now is just go f of, what value am I plugging in? How about that? Okay? Gives you an answer.
But how do we
do
get that to radical? So are we?
Oh, I see what you're saying.
So do you want the answer like that, or do you want it in radical?
No, I would let you just. On these applications, I'll just have you round it to. I'll tell you what to round it to. Yeah. And I would take either one. Would be fine.
So then,
On
would
your.
you do that one on here? Are you saying like in the y equals right here?
Okay. So the other way you can do it on your calculators, I'll show you on your calculators. This is pretty handy too to know. So on your graphing calculator, you can just do it this way. You can do we can set up the expression. And if you want to make this look right, you guys know the trick, you go alpha F1, and you can use your fraction template. That's a pretty good little trick. So we'll go square root, I'm going to put the 2 out front for the S dot. So 2 times the square root of x squared plus x to the, where's my, below the, where's clear, oh, right there, yeah, there we go. X to the 4th over x plus 2x cubed. Okay, and then I'll hit enter. It's going to give me some gibberish, but then I can come down and I can set, x is supposed to be 6, right? So I can do 6 store x, and I hit enter. So what'd that just do? Yeah, that set the value of x to 6, and now all I have to do is go up and grab that expression and hit enter, and what do you know? I get the same.
Yeah, how'd you
It's
get that?
above on, it's above.
Oh, you know what's really bizarre? I mean, what were the odds of that?
Then it was already 6.
It was already 6.
Yeah.
So the last thing I did on the calculator ended up with x being a 6 just randomly. That's pretty weird. I did not plan that, I promise you.
We have not been taught the store thing. That was the first time we used the store.
Really?
Yeah.
Oh, I go through all that stuff in Algebra 2. That's because we do a lot of these computations in Algebra 2. So, okay, so that's pretty helpful. And then the other thing you can do too, I'll show you on your, while we're looking at this, kind of just a practical consideration. Because just in case we don't, I mean, we'll get to this again, but good to see it more than once, especially going into college, especially like in lab situations. If you want to do, here's another thing you can do. You can go into, you can set y equal to, and let's clear that. And let's put this in again. So we're going to go use our fraction template, square root. Oh, I forgot my 2, didn't I? I can put it out there, that's fine. 2 times square root of x squared plus x to the 4th over x plus 2x cubed. Okay? And then you can go down to, well, a couple things you can do. You can do this, you can go to window, and then if you know, let's just say, yeah, this will work. This will be good too. So let's say you know all the values you want to plug in are going to be between, let's say, 0 and 20. Then I can set my window to go, my x min is 0, my x max is 20, and that's the key part. You have to just pick value. You have to set your window around x values you're going to use. And then while you're at it, when you set you guys know this trick, I hope. When you set the x values, you know about zoom fit?
What? We went
Okay.
over it last time.
Okay. So when you set the x values in your window on your graphing calculator, if you go down to zoom fit, which is zoom 0, it's right after zoom stat. So you can literally just type zoom and then hit a 0. It's going to fit the screen vertically so that it matches the domain that you chose. Okay, that's pretty handy to know. And then all you need to do, if I want to evaluate this thing, I can just go, check this out, I can just go trace 6, enter. There it is. It only gives it to you it doesn't give it to you to as many decimal places. But I can just do, like I could do trace 9, enter, and there it is at 9. Okay, so you can get repeated values that way. Another way to do it, once I've set y in there, is I can go to table. I can set up a table. So if I go second table set, I can choose my start value. So like if I want to go by ones, for example, I could start at 1, and I'm going to go down and do my delta table. So my increments are going to be I'm going to go by ones. And for my, I think I can even do this. For my independent, I'll show you this first, and I think I got another trick for you. So now look, if we go to table, which is second table, look what it does. It's giving me all the values here for every, it's evaluating the function at all these different values of x. If I go back to, and I think this is going to work, we'll see, I'm kind of excited to find out. If I go down to independent and I do ask, okay, now let's see what happens. If I go second table, yeah, let's look what it does. I can type in a value. Like I can type in 6. I can type in 8. See what I'm saying? That's pretty good. Yeah, it's on tape, so it's on the video, so you can go back and look at this. Okay. If you want to do, okay, well while we're on a roll here with this stuff, because I think I've showed you all the related rates problems I need to. So if you go to in Desmos, here's another thing you can do in Desmos with this. In the graphing, if you go up to add an item and you go to table, actually I don't want to do that yet. I want to do this. I'm going to set up a function. I'm going to set up f of x equals, and then I'll just set this same one we've been using. So it's 2 square root. If you type in sqrt, it gives you a square root. Okay, so obviously this is, you can do the same thing you did before. I can just do like f of 6.3 and it's going to give me an answer. Okay, but the other thing I can do is I can add a table down here. If you need repeated values, I can go table, and it's in terms of x1 and y1. But I think for y1, I believe I can do f of x1. Yeah. And look, it's going to do it. So like I could even do like 1, what if I'm going by 0.5s? 1.5, 2, and then it just knows the pattern. Pretty cool. Right, so if I want to get repeated values, I can use that table feature. Okay? And look, it even graphs it for me, which is kind of cool. It even graphs all those points on the graph. Okay. All right. So just some nice little computational tricks. I mean, really, last part of this, I guess. Yeah. So we can calculate, it's pretty easy for us then to just plug and chug and get x dot, right?
Yeah.
When we want to get y dot, the last little part of this is, look, we can go back to this secondary equation that relates y and x. Now that works. That's telling me this is how y and x are always related, right? That has to always apply. And so if we come down here, we could say if y equals x squared, then if I differentiate with respect to t, I'm going to get y dot equals 2x x dot, and I know everything there, right? I can plug all those values in to get y dot, okay? This might seem like this is still like, wow, what would you think of that stuff? But this is exactly, we're going to continue this thread when we get into optimization. And it's even going to be, like there, it's not even really an option. There, we have to write the function of a single variable. So it's going to, you're really going to get used to that idea of utilizing a secondary equation to write it in terms of a single variable. That's going to get hammered home a lot. Yeah.
So for the y dot, are you going to want us to insert our x dot
Yeah.
equation into the x?
No, you would just,
or you can just use that
no,
rounded value?
we just calculated x dot. So it's just going to be, we're going to get, from this, we're going to get some number
Yeah, it looks like
that we'll just plug in right there.
Okay.
Okay, now here's something else too, another little computational thing too. And this is something that like we would have talked about like in physics, we do this all the time. when you're doing a computation and you're using calculators, for example, let's say that based on the numbers being used, that you can only keep 3 decimal places or something, right? Or 3 significant figures when you're calculating how many sig figs you can keep. Can you round during the process? You should never round during the process. You should keep infinite sig figs until you get an answer, and then you round. You only round on the last step. That's sometimes I can remember, I was actually taught that incorrectly in high school. Sometimes, there's an assumption made that if you can keep 3 sig figs, that I can start with my initial calculations and round to 3 sig figs. You do not want to do that. You do not want to accumulate rounding error throughout the process. You want to keep as many as possible and only round at the last step. Okay, that make sense? Okay. The other thing you could do though, that was plan A, where we plugged in what S was down here. What we also could have done right here, right, at this step, is I could have gone up here and just made another row, or another value. I could have gone up to my initial snapshot values, and I could have just calculated what the numerical value of S is and plugged it in there. You get that too, right? Either way would have worked. Okay. Does that make sense?
Yes.
Okay. Are we out of here in 3 minutes?
Yes.
Yeah. Yep. Yeah.